Okay, we're going to do another example of free body diagram. So in this problem we have three bodies that are attached, and it asked me to draw a free body diagram for all three. So I have first isolate the body. So there's one of the bodies, there's a second body, and there is the third body isolated. Fortunately, drawing super good is not required to be a good physicist. Now, I need to inventory the forces, so I have W1, weight of this one is W2, weight of this one is W3. Next, I have to find any applied forces. No, there are no applied forces. There's no springs, there's no Johnny, there's no Sue pushing on it. Then next, after WA is in, normal, is it touching a surface of contact? No, they're not touching a surface of contact. Then it's T for tension. Yes, there are some ropes. There is a rope here that's attached to the top of this. Ropes don't push, so it has to pull. So it's pulling up. That's T1. Then I have a rope at the bottom. Oops, let me undo that. I have a rope at the bottom pulling down. I'll call that rope T2. There's no reason to believe the tension would be the same in both ropes. Now, who is pulling on this tension? Well, the answer is the little green slice here. The green slice pulls on this sphere with a tension T1 down. Then the sphere must pull on the green slice with the tension T2, the same magnitude. So it was pulling with T2, then this one has to be pulled by that with T2, and it has to be up. Notice it has to be the same type of force, it has to have the same symbol, and it should point in the opposite direction once you put down your axes. Then this one, in addition to having this upward force on this thing, has a downward force applied by this kind of unusual reddish looking shape. So that's attached here and it goes down. That's T3. But if the red applies a T3 tension force down on the green object, then the green object must apply a tension force T3 up on the red object. So we have a set of tensions. Anything else? Friction? No, there's no friction. So that's it. Then we need to put some axes. I'm going to put my axis for X and Y, and in fact I'll put the same coordinate alignment for each of the other free body diagrams. Every free body diagram has its own axis set. For a problem like this, the axes don't rotate or change, but for some of the later projects, if we rotate or change them in our choice, we can greatly simplify their math, and you can watch the other videos to see that. Last but not least, we look, is there any critical angles or dimensions? There are no critical angles or dimensions in the problem because each one of these arrows is aligned to either the Y or the X. In this case, they're all aligned along the Y-axis. So we're not going to need any trig. There's no breaking vectors into components for this particular free body diagram. And that's it. That's a free body diagram.